Beneath the surface of the earth, far below the attention of most living creatures, a quiet transformation is always underway. There are no footsteps here, no sunlight, no dramatic motion. Yet this hidden world is in constant activity, shaped by bodies that move slowly and without sound. Among them, the earthworm holds a position of unmatched importance. Earthworms are not predators. They do not chase, ambush, or defend territory. Their power lies in persistence. Through endless repetition of simple actions, burrowing, feeding, excreting, they alter the physical and chemical structure of the land itself. Fields, forests, grasslands, and gardens owe much of their fertility to this unseen labor. Scientifically classified within the phylum Annelida, earthworms are segmented worms whose evolutionary history stretches back over 600 million years. Their ancestors lived in ancient oceans, long before plants colonized land. Over time, some lineages adapted to life in moist soil, transforming from marine organisms into terrestrial engineers. The body of an earthworm is deceptively simple. Long, cylindrical, divided into repeating segments, it lacks eyes, limbs, or a hardened skeleton. Yet within this simplicity lies remarkable efficiency. Each segment contains muscles, nerves, and blood vessels, allowing coordinated movement through soil. By contracting and expanding these segments, the worm pushes forward, creating tunnels that permanently alter the ground. Movement is aided by tiny bristles called setae, which grip soil particles and provide traction. This allows the earthworm to anchor itself as it moves, preventing backward slippage. Every motion displaces soil, mixing layers that would otherwise remain separate. Over time, this mixing improves aeration, drainage, and root penetration. Earthworms breathe through their skin. Oxygen dissolves in moisture on their surface and diffuses directly into the bloodstream. This reliance on moisture dictates their habitat. Earthworms thrive in damp, well-structured soils and retreat deeper underground during dry or cold conditions. Rain brings them to the surface, not out of preference, but necessity, as saturated soil contains less oxygen. Feeding is constant and indiscriminate. Earthworms consume soil, decaying plant matter, fungi, and microorganisms. What they cannot digest passes through their bodies and is excreted as castings, nutrient-rich pellets that are chemically distinct from surrounding soil. These castings contain higher concentrations of nitrogen, phosphorus, and potassium, making them invaluable to plant growth. In this way, earthworms function as natural recyclers. Dead leaves, fallen wood, and organic debris are broken down, transformed, and redistributed. Nutrients locked in decay are returned to the soil, accessible once again to roots and microbes. Without earthworms, decomposition slows. Soil hardens. Productivity declines. Their tunnels serve additional purposes. Water infiltrates more easily, reducing runoff and erosion. Roots follow these pathways, reaching deeper layers where moisture and minerals persist. Microbial communities flourish along tunnel walls, forming networks of interaction that stabilize entire ecosystems. Reproduction in earthworms reflects the quiet efficiency. Most species are hermaphroditic, possessing both male and female reproductive organs. During mating, two worms exchange sperm, ensuring genetic diversity. Fertilized eggs are encased in cocoons deposited in the soil. From these, young worms emerge already equipped for the same subterranean life. There is no parental care, no protection beyond concealment. Survival depends on conditions. Many do not reach adulthood. But those that do may live several years, continually reshaping their environment with every movement. Despite their importance, earthworms often go unnoticed, or worse, misunderstood. They are associated with dirt, decay, and discomfort. Yet their presence is one of the clearest indicators of soil health. Where earthworms thrive, ecosystems are usually resilient. Agriculture has learned this lesson slowly. Fields rich in earthworms require fewer chemical inputs, retain water more effectively, and recover faster from stress. Practices that preserve soil structure, reduce tillage, organic matter retention, support worm populations and, by extension, long-term productivity. Still, earthworms face threats. Soil compaction, pollution, pesticides, and habitat disruption reduce their numbers. When they disappear, the consequences ripple outward, often unnoticed until degradation becomes severe. The earthworm does not defend itself. It does not adapt quickly. It relies on stability. In return, it offers transformation. Every tunnel is a decision. Every casting is an investment. Every movement reshapes the ground. And all of it happens beneath our feet. For most of human history, the earthworm worked unnoticed beneath expanding civilizations. Fields were plowed, forests cleared, cities raised, yet the silent labor below continued. Only recently has science begun to fully understand how deeply human survival is tied to this modest organism. When industrial agriculture emerged, soil was no longer treated as a living system, but as a medium to be exploited. Heavy machinery compacted the ground. Synthetic chemicals replaced organic cycles. In many regions, earthworm populations collapsed. Yields initially increased, but soil resilience quietly declined. Where earthworms vanish, soil loses its structure. Air pockets disappear. Water runs off instead of soaking in. Nutrients wash away. Crops become increasingly dependent on artificial inputs, creating a cycle of dependency that grows harder to escape with each season. Yet in places where earthworms are protected, the opposite occurs. Regenerative farming practices, cover cropping, compost use, reduce tillage, restore underground life. Earthworms return. Soil becomes darker, softer, more stable. Productivity increases not through force, but through cooperation with natural processes. Not all earthworm activity, however, is universally beneficial. In some ecosystems, particularly northern forests that evolved without native earthworms, introduced species have altered soil layers dramatically. Leaf litter disappears faster than plants can adapt. Native understory species decline. Even organisms that build can disrupt when removed from their original context. This duality reveals a deeper truth: balance matters more than presence alone. The earthworm is powerful not because it dominates, but because it fits precisely into its environment. When systems are pushed beyond their natural limits, even helpful organisms can become agents of change, sometimes irreversible. Climate change adds another layer of uncertainty. Rising temperatures, shifting rainfall patterns, and prolonged droughts alter soil moisture and chemistry. Earthworms respond by moving deeper, slowing reproduction, or disappearing entirely from regions they once stabilized. What happens underground often precedes visible change above it. Scientists now monitor earthworm populations as early indicators of ecosystem stress. Their absence can signal degradation long before crops fail or forests thin. In this way, earthworms function as living sensors, quietly recording the health of the planet beneath our feet. Philosophically, the earthworm challenges human perception of importance. It has no voice, no beauty by conventional standards, no claim to dominance. Yet without it, much of terrestrial life would struggle to persist. Complexity does not always announce itself. Power does not always demand attention. The earthworm does not compete. It does not conquer. It transforms, through repetition rather than speed, through consistency rather than strength, through cooperation rather than control. Every fertile field, every stable forest floor, every resilient ecosystem carries the imprint of its movement. Not as a signature, but as a foundation. In the end, the earthworm reminds us that progress does not always move upward or outward. Sometimes, it moves inward, downward, slowly, in silence. Beneath our feet, the planet is being rebuilt, segment by segment.